Okay, we're going to solve a few formulas, and this is always somewhat troublesome. I don't have a lot of other things to talk about, so I'm going to say a lot of this kind of quickly, but I'm going to say it as completely as possible. Okay, we got x, y equals p, z. Now I'm circling the variable that I want you to solve for. Normally you have the equation, and then you have the instruction solve this equation for q or whatever it is. I just circled them to avoid having to write all that. And also because it's a good idea to circle the variable you want to solve. So here we have x times y equals p. I've circled the y. Okay. X is multiplied by y. Okay, we obviously want to get rid of x. If we get rid of x, we got y. Okay, so we're going to get rid of x on the left. So I'll say divide by x. Now, when I say divide by x, for solving an equation, I mean divide both sides by x. I didn't want to write all that out just for the sake of space, but I'll put in both sides here, and you might not even be able to read that back there. But I think you understand that because you've been doing it. Okay. So we divide both sides by x. So we get xy divided by x equals pz divided by x. Okay. Then x is a factor of the numerator. X is a factor of the denominator. In other words, everything else in the numerator is multiplied by x. That's what we mean by x is a factor. Okay. So I'll say that kind of completely. Everything in the numerator, that's not a real good way to say it. I just thought it was much better to say. I'm going to say that x multiplies the entire rest of the numerator. Y over x. Okay. X in the denominator divides x in the numerator. Thus, xy over x equals y. And I realize, I like to start, I like to write over here because I've been blocking the board as I write along this stuff, okay? And I prefer not to block the board. And okay. So we can write y equals pz over x. And that's our solution. Okay. Now we can check this. If we plug this back in here, well, xy equals pz. So if we plug this in for y, x times pz over x equals pz, right? So x pz divided by x equals pz. And x is, again, a factor of the numerator. X multiplies the entire rest of the numerator, meaning it's a factor. Okay? That's what it means to be a factor. The whole rest of the numerator is multiplied by x, and the denominator is x, so they can be divided, and x divided by x is 1, and that just leaves us pz equals pz, right? So there we are. Okay? Wrote it kind of small. This statement here means exactly what we mean when we say x is a factor of the numerator. Okay? So open math will tell you just draw a line through these x's. It's dangerous because people draw lines through things they shouldn't. But if you keep in mind that you draw a line through a factor of the numerator and the same factor of the denominator, then it's okay. But you have to know that rule before you do. All right, well, let's move on. We've got AP equals 3 minus P. And we're trying to solve for A. So what do? We divide both sides by P. Now I'm going to write that a little. I could say divide VS for both sides by P, but that would have other connotations. Okay, we don't use VS for abbreviation. Divide, I'll just say divide both by P. And both means both sides. So we have AP divided by P equals 3 minus P divided by P. Now here's where you got to be careful. Okay, P is a factor of the numerator and a factor of the denominator, right? I'll say so it divides out, and we get just P. We get just A. Be a factor of the numerator. What's it mean to be a factor? It means it multiplies the entire rest of the numerator, right? Does P multiply the entire rest of this 3 minus P? No, P is not multiplied by 3. Okay? So you can't cross those. You can't divide out P. P not B. Majority of people try to do that. They'll just cross a line through and say the answer is 3. Okay. Totally wrong. Okay. Now, what we can do here is this. This is a distributive law. You divide 3 minus P by P, means you got to divide 3 by P, and you got to divide minus P by P. Okay. Get from here to here, we use the distributive law on the right-hand side, so that A equals 3 over P, and P divided by P is 1. Now, even if there's some people cross out both P's and then just leave it off. Yeah. Cancellation is not crossing out. Cancellation is division of something by itself. Okay? So we're dividing P by P, and we get 1. You put a line through this and leave it off. Okay? Very common. Very common because people don't know. Generally, when they come out of Algebra 1 and Algebra 2 courses, they don't know what cancellation means. They just know they cross things out under certain circumstances. They learned it long enough to pass their tests, and it never made sense. So they stopped doing it, and they don't do it right. Okay? I'm hypothesizing. I can't really say exactly what's going on in anybody's head, but I think it's pretty much like that. All right, now, R plus SW equals Z. And we want to solve for W. Okay. We could isolate W to an extent if we divide both sides by S. Okay. We should have to divide R by S as well. And that turns out to be kind of counterproductive. Okay. I said last time, S is multiplied by W. R is added to the expression with W. We get rid of additions and subtractions before we do multiplications and divisions, just like the order of operations. Okay, so subtract R from the sides. Do addition and subtraction before multiplication and division. So we do R plus SW equals C. I don't like to write it out the way I'm going to write it out. but it's a habit everybody has. And I found out yesterday there's an even worse thing that happens when people do this. So I really don't like this. I was kind of okay with it until yesterday. Okay. And I saw people doing stuff that it just can't be done. Minus R equals minus R. Okay. That's interconvertible. So this side equals this side equals this side. So if I add this and this, I get the same thing as if I add this and this. So what I do is, I'm going to write this out. This is the step I want to see. I don't want to see anything disappearing. I don't want to see any calculation done. I want to see R plus SW minus R equals Z minus R. We just tack on a minus R on both sides. Okay? This is the way it ends up. And people are doing completely wrong things when they write it out like this and don't write it like this. So I want to see this step. Make sure we've got it. Okay. Now, R minus R is 0. And so R minus R plus SW minus R just equals SW. It equals, we can rearrange this. We put the R, the minus R next to the R. R minus R is 0, and 0 plus SW is SW. So I'm kind of skipping that. Until I see others, people don't understand it. Okay, so SW equals Z minus R. So what do we do now? Well, we're trying to get W. And it's pretty obvious what we do now. Just like what we did over here, we divide both sides by Z, right? Not by S. Oh yeah, my hand doesn't look good erase. Okay. S is a factor of the numerator and of the denominator. It is the denominator, so it's certainly multiplied by everything else in the denominator, which is 1. Okay. So S divided by S is 1, and we get W equals Z minus R over S. Now the flow of the problem, and the reason for it is, we pick on R because it's added to an expression of W. Subtract it from both sides. We don't divide by S because we can subtract something from both sides or add something to both sides. Don't do any divisions until you've done your additions and subtractions. We do that. We're careful with this step. We put the equal sign between the two things that we're adding to both sides. We're adding a negative R. And then we write out what we get. We just write out whatever this is, and then the minus R, and whatever this is, and the minus R, and we've added them. Then we simplify this. R minus R is 0. We get SW equals Z minus R. S is a factor of the numerator. So we can divide, or S is a factor of SW. So if we divide both sides by S is a factor of the numerator. It is the denominator. We can divide it out and we get the result. We need to understand that. We need to have that narrative going in our heads every time we do a problem like this, so that we're sure that we're following the rules. Okay, We're not force fitting. For this last one. Okay, we've got further I am over here, the less I block the board. So this happens. We have A, B plus C equals D, B plus E. I circle B. So that's a variable we want to solve. Now we got another B over here. So I'm going to circle that and remind myself I've got them on both sides. Now what am I going to do about that? Well, if my B's are split between two sides, I can't do anything. I need to get everything with a B in it over on the left. So what I do, well, no, well, I can get this B on this side if I subtract dB from both sides. Okay. Okay. I'm going to do that. And I'm going to write it out like this, like people are in the habit of doing. I think it's questionable pedagogy, but for good reasons. And we do minus dB equals minus dB. And we add this and this, we add this and this. So we get AB plus C minus dB, circle our B so we can keep track of them, equals dB plus E minus dB. I want this step. I don't want it just to go away because people do wrong things when they try to go from here to the next step. I want it literally written out. AB plus C minus dB equals dB plus E minus dB. Okay. Then we can say dB minus dB equals 0. So dB plus E minus dB equals E. Now we have AB plus C minus dB equals E. What are we going to do with that? We still got two terms with dB in them. Well, let's not worry about that. We want to get rid of C, don't we? Plus, I'm going to get rid of A and D. But we want to get rid of C because, first, because C's added to everything else. A, B, and DB both multiply things by D. Order of operations applied to the equation says we're best off if we get rid of C. So we subtract C. So we'll do minus C equals minus C. We write it out, AB plus C minus DB minus C equals E minus C. We don't do anything but just write out this side and tack a negative minus C on it. This side, tack a minus C on it. Well, C minus C equals 0. So we'd end up with just AB minus DB equals E minus C. Well, now we factor B. This is a distributive law, but used backwards. Okay. It means AB minus DB is B times A minus B. By the distributive law, B times A minus D. I'm going to write it differently just so there's a little point of confusion when I chose to write this. Okay, I'm going to write this as A minus D times B, just so I have things in a more convenient order. Okay. We can't argue with this. A minus D multiplied by B means that A multiplies B and the minus D multiplies B. That's the distributive law, which of course need to have deeply ingrained. So that's our reason for these two steps. Now, we divide both sides by A minus D. A minus D is a factor of the numerator. It multiplies everything else in the numerator, which is just B in this case. And A minus D is the denominator, so A minus D will divide A minus D, and we get D equals E minus C over A minus D. There's our solution. Now we can check that. Plug this in for B here, plug it in for B here, and do some stuff, and we verify it. That's a little more complicated, and I'm not going to do it right now, not because I don't think it would be a good idea, but because we have other things we have to cover. That gives you a pretty good range. These four examples, I think, give you a pretty good range of what you can do to solve fairly simple formulas, okay? The principles apply again and again. We've used every possible principle for solving equations. We can add the same quantity to both sides or subtract, okay? We can multiply or divide on both sides by the same quantity, okay? Those are the two things. We can divide factors of a numerator by equal factors of the denominator. You have to know what a factor is. It's something that multiplies the whole blame rest of the numerator, okay? And the whole blame rest of the denominator, right? And then it comes down to tricks. And we use one trick here. When we have B on both sides, I only circled it here, but you know, I recommend that you circle it if you're going to circle B, you circle them all so you know where they are. You go blind looking at a long formula, you can miss something if you haven't circled the variable that you're trying to solve. After you've done a bunch of them, you probably don't need to do that anymore, but it doesn't take long to circle your variable. All right. And also we have the principle that we always check. I only check the first one. Every one of these should be checked. If you can solve the formulas in the open math assignment, and it's a class, the class solved a majority of them. So it wasn't terrible, but when we have a quiz, I don't see the principles being clearly followed. Same principles we use when you have numbers in the equation. Okay, so we're gonna need more practice on that. Now we're getting toward the end of elementary algebra because this is the new intermediate algebra course, and we've had almost 3 weeks. We will have had 3 weeks of review of elementary algebra. Okay, so we do need to get this stuff down. We could spend just a little more time on it if necessary. But then that kind of rushes intermediate algebra, and you really don't want to do that. All right, well, we're going to do a couple more things now, a couple pretty straightforward things, a whole lot easier than this. Okay. Solve this one for x, solve this one for y. Just like solving linear equations, except you have the greater than and less than sign, but there is one little trick that most people forget. So I'm going to see if you remember it, but don't feel bad if you don't. You're among the 90% who don't. Okay, but I wouldn't be surprised if you know it. Okay, briefly, we'll solve these inequalities. We've got 2x plus 3y less than 12. We want to solve for x. We don't want that 3y, it's added, so we can get rid of it. We do 2x plus 3y minus 3y less than 12 minus 3y. You'll notice that I'm not doing this thing about doing a minus 3y equals minus 3y and adding it. I'm finding that that's much more distraction than it's worth. We write things out like this. If you're doing it the other way, as long as you're right, I'm all right with it. If you make a mistake, I'm going to say, I told you so, gently and kindly. Okay, so 3y minus 3y is 0. That gives us 2x. It's less than 12 minus 3y. We divide both sides by 2. And 2 is a factor of the numerator. It is the denominator. So we can divide the 2 by the 2. It's just x less than 12 minus 3y over 2. Some people want to cancel the 2 with the 12. You can't. This means 12 over 2 minus 3y over 2. If you want to simplify it, you have to break it in 2. Then you can divide the 2 into the 12. But you still have the minus 3y over 2. So I'm saying leave it the way it is for right now. Okay. The other one. 4x minus 5y greater than 20. We're going to solve for y. I just write down this side with a minus 4x. I write down this side with a minus 4x. 4x minus 4x is 0. We have minus 5y greater than 20 minus 4x. Now we want to divide both sides by negative 5. So we do negative 5y over negative 5. If we multiply or divide by a negative sign, the inequality reverses. So we've got to reverse the inequality. We have 20 minus 4x over negative 5. And this leaves us y less than 20 minus 4x over negative 5. Or y is less than 4x minus 20 over 5. This answer would be kind of all right. We usually don't want the negative in the denominator. If you don't understand how we get from here to here, ask and I'll explain. Okay.